Hello, everyone. Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. Today's lesson is for students in grade 3, but all of you are welcome to join in. My name is Trisha Blaylock. I'm a second grade teacher at Grant Elementary in Spokane Public Schools, and I will be your teacher for this session. I'm so glad you're participating with me today. Today we will get our brain ready to practice multiplication by making equal groups, skip counting, and using repeated addition. For today's lesson, you will need paper and pencil or a dry erase board and marker if you have one. I will give you a moment to gather your supplies. Let's get started. Let's get warmed up. Which one doesn't belong? Can you defend your answer? Maybe you said the circle doesn't belong, since it's the only one that is not a rectangle. Or maybe you thought this one doesn't belong, since it's the only picture showing a fraction other than 2/3. Did you choose this one, since it is an orange? Or maybe this one because the shaded pieces are not right next to each other. All of these observations and others you may have had are mathematical noticings. Let's try another one. Which one doesn't belong and why? Did you think 2/8 doesn't belong because its numerator is not a 1? Or maybe you thought 1/2 doesn't belong because you discovered that the rest are equivalent to 1/4. Or did you choose this one because it's not numbers? All of these fractions could be defended mathematically as the one that doesn't belong. Here's our last warm-up. Which clock doesn't belong? Maybe you thought the top left doesn't belong since it's the only clock with the minute hand not at 45 minutes. Or did you choose this one because it doesn't have tick marks for the minutes like the rest do? This clock doesn't have numbers like the rest. Maybe it doesn't belong. Did you notice that this is the only clock with the hour hand not pointing between the 1 and the 2? Before we get started, let's review some vocabulary. That last which one doesn't belong featured analog clocks. Analog clocks show the time using hands, so they are not digital where we see a display of the current time. On an analog clock, we can see the amount of time that has passed and the amount of time left in an hour. A fraction is a number expressed as some part of a whole, and those parts must be equal to each other. Today, we're going to think of fractions of an hour. We'll be collecting equal parts of an hour to create fractions. Let's explore 1/2. What is 1/2? A half is one part when a number, shape, or set is divided into exactly 2 equal parts. 1/2 of an hour is 30 minutes, and we could shade in 1/2 hour on an analog clock by coloring in the sections between the 12 and the 6. Let's start collecting half hours. Each time I spin a number, we will add that number of half hours by coloring in on the analog clocks and completing the chart. Let's say we spun a 3. 3 half hours is 90 minutes because 30 plus 30 plus 30 equals 90. 90 minutes as a fraction of an hour would be 90/60ths, or 90/60. Because we collected 90 minutes, that's our numerator, which goes on the top, and 60 minutes is 1 whole hour, so that would be our denominator, the bottom of our fraction. That fraction could also be written as 1 30/60ths, or 1/2. So we've collected a total of 90 minutes, which is 1.5 hours. So let's say our second spin, we got a 2. So if we have a 2, and we're going to collect 2 half hours, well, 2 half hours is 60 minutes or a whole hour, and I know that because 30 plus 30 equals 60. 2 half hours as a fraction of an hour would be written 60/60ths, or 60/60, and that could also be notated as 1/1, or 1 whole, because we've collected 60 minutes, and 60 minutes is 1 whole hour. So far, we have collected 150 minutes, since 90 from our first turn plus the 60 from our second turn equals 150. Our total minutes collected would be written as a fraction as 150, what we've collected, over 60, 1 whole hour, which is also the same as 2.5 hours. So for our third turn, we spun a 1. 1/2 hour is 30 minutes. 1/2 hour written as a fraction of an hour would be written as 30 over 60, which could also be notated as 1/2. Now, if we find the sum of our collected minutes, we've collected 180 minutes. Since 90 from our first turn plus 60 from our second turn, we already know that that was 150, plus 30 more would be 180. Our total minutes collected written as a fraction is going to be 180, what we've collected, over 60, what is equal to 1 whole hour. That is equal to 3 whole hours. Let's say for our last turn, we spun a 3. We already know that 3/2 hours is 90 minutes. And we know how to write 90 minutes as a fraction from our first turn. But now, if we find the sum of our collected minutes, we need to add another 90. So the 180 that we had before plus 90 equals 270. Our total minutes collected now, written as a fraction, is 270 60ths, or 270 over 60. And that is equal to, or equivalent to, 4.5 hours. So in our 3 turns, we collected 4.5 hours. Let's explore 1/4. 1/4 is 1 part when a number, shape, or set is divided into exactly 4 parts. And 1/4 is also called a quarter. 1/4 of an hour, or 1/4 hour, is 15 minutes. And we can shade in 15 minutes, or a quarter of an hour, on an analog clock by coloring in the sections between the 12 and the 3. This time we're going to be collecting quarter hours. So we'll do the activity the same way by spinning a number and filling in our analog clocks and our chart, but this time we're collecting only quarter hours, or 15-minute chunks at a time. Oh, for our first spin, we got a 1. So 1/4 hour is 15 minutes, and that would be written as 15 60ths as a fraction, and then that could also be written as 1/4. So we have a total of 15 minutes, or 1/4 of an hour. For our second spin, we got a 3. 3/4 hours is 45 minutes. I know that because 15 plus 15 is 30, and another 15 would be 45. 45 minutes written as a fraction of an hour would be 45 60ths, and that is the same as 3/4 because 15 goes into 45 3 times, and it goes into 60 4 times. So our total number of minutes collected now is 60 minutes because 15 from our first turn plus the 45 from our second turn equals 60. And we know that 60 is 1 hour, so 60 over 60, or 60 60ths, is equal to 1 whole hour. For our third spin, we got another 3. So we know that 3/4 hours is 45 minutes, and we know how to write that as a fraction. But now we need to figure out how many total minutes we've collected. We started with 60 minutes, and we're adding 45. So I know that 60 plus 40 is 100, and then I'll need to add that 5 in, which would give me 105. So we've collected 105 minutes. 105 minutes can be written as a fraction of an hour as 105 60ths. And if we work that out, I know that that then is going to be 1 whole hour plus 3/4 hours, or 1 3/4 hours. So for our last turn, we spun a 2. 2 quarter hours is equal to 30 minutes because 15 plus 15 equals 30. To write 30 minutes as a fraction of an hour, we would write it as 30/60ths, or 30 over 60. And I know that that's going to also be the same as 1/2 hour because 30 minutes is half of 60 minutes, or an hour. Now, when we're talking about fractions of an hour, the denominator, or the bottom number, is going to be 60 because there are 60 minutes in a whole hour. Let's look and see what we've collected so far. We started with 105 minutes and now we're adding 30 minutes, so we're going to get 135 minutes. And our total of 135 minutes can be written as a fraction as 135/60ths. And I know then when I shade in my analog clocks that that's going to be the same as 2 1/4 hours. So we collected a total of 2 1/4 hours. The last fraction we're going to talk about today is 1/3. 1/3 is 1 part when a number, shape, or set is divided into exactly 3 equal parts. And 1/3 of an hour is equal to 20 minutes because it would take 3 20s to equal 60, or 1 whole hour. We can shade in 1/3 of an hour on an analog clock by filling in the numbers between the 12 and the 4. We're going to continue to collect fractions of an hour, but this time collecting thirds of an hour, or 20-minute sections, by coloring in on our analog clock and filling in our chart. For our first spin, we've gotten a 1. 1/3 of an hour is 20 minutes. And we would write that as a fraction as 20/60ths. And 20/60ths would be equivalent to 1/3 of an hour, or 1/3. And we have a total of 20 minutes collected. For our second spin, we got a 2. 2/3 of an hour is going to be 2 sets of 20, so that's going to equal 40. And to write that as a fraction of an hour, we would write 40/60ths. And 40/60ths is equivalent to 2/3. I know that 40/60ths is equivalent to 2/3 because 20 goes into 40 2 times, and 20 goes into 60 3 times. So that means it takes 2 20s to make 40, 20 plus 20, and it takes 3 20s, 20, 40, 60 to make 60. So our total number of collected minutes now is 60 minutes because 20 plus 40 equals 60 minutes. And we know from all of this learning that we've done so far that 60 minutes is 1 whole hour, and that would be written as a fraction as 60/60ths, or 1. So we have collected 1 whole hour. For our third spin, we got a 3. 3/3 of an hour is going to be 3 20s, or 60 minutes, because 20 plus 20 plus 20 equals 60. And to write 60 minutes as a fraction of an hour, we were going to write 60/60ths. And we know that that's going to be equal to 1 because 60 minutes is 1 whole hour. To find out how much we have collected in all so far, we're going to add this 60 minutes to our previous 60 minutes. And 60 plus 60 equals 120. To write 120 minutes as a fraction of an hour, we're going to write it as 120, the number of minutes we've collected, as our numerator on the top of our fraction, over 60, the number of minutes in an hour, on the bottom as our denominator for our fraction. 120/60ths is the same as 2 hours, so that is 2 hours that we have collected so far. Here's our last spin. We got another 3. So we know that 3/3 of an hour is equivalent to 60 minutes, which is the same as 1 whole hour. Now we just need to figure out how many total minutes we've collected by adding this 60 minutes to the previous 120 minutes. So 120 plus 60 equals 180. And to write 180 as a fraction of an hour, we would need to write 180 over 60, or 180 60ths. Now the number on the top, our 180, our numerator for our fraction, is representing the number of minutes that we've collected, and the 60 on the bottom of our fraction, the denominator, is representing how many minutes are in a whole hour. Now 180 over 60 is equivalent to 3 whole hours. So we collected this time 3 hours. Let's take a look at our recording sheets for collecting halves, thirds, and fourths of an hour. What do you notice? Well, I noticed that as we were playing, we collected whole clocks a lot faster when we were collecting half hours than when we were collecting quarter hours. And I know that 1/2 is more than 1/3. And I know that 1/3 is also more than 1/4. So if I look at these fractions, and if I take a look at the denominator, the bottom number, if that number is smaller, that means that there are less pieces needed to make a whole. So those pieces have to be bigger. And it would make us be able to collect a whole faster than if we're collecting smaller parts like quarters. What are some things that you notice? Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. If you didn't see our previous lessons, you are welcome to go on the KSPS website. Sometimes it's helpful to go back and watch the other lessons in our series so you can continue to build your understanding of the mathematics we will be doing together.